So far we discussed questions to how to find the probability of particular event, like about dice, about coins and etc. Now we are going to do something different. We have probability given in the question. We need to find the number of favorable outcomes indirectly, like number of blue balls, number of rotten apples, good apples, like that. Okay, let's start with the question. Let's read first. The probability of selecting a rotten apple randomly from a heap of 900 apples is 0.18. Okay, so there are 900 apples, right? And some of them are rotten, some of them are good. So probability of getting the rotten apple is 0.18. What is the number of rotten apples in the heap? Okay, very interesting. So first of all, just for the purpose of understanding, let's write over here that 900 apples are there. Okay, so let's say these are rotten and these are good, right? It can be divided into two parts. We want to find the number of rotten apples. We are not interested in the good one because it's not mentioned anything about that in the question, so don't bother about it, right? Now one more thing is given, the probability of rotten apple. Okay, probability of rotten apple is equal to 0.18. okay, so how shall we proceed? You have the very simple step, but you need to apply the formula in the correct way. Let's start with the formula only. It's all about the formula. So probability of rotten apple, how can we write the formula first of all? Okay, favorable outcomes. So if you take one apple from this, first of all let's write the total number of apples that will come in the denominator. Total outcomes. Instead of outcome, I'm going to write apple, right? Total number of apples, numbers, right? And rotten apples. Why rotten apples? Numbers, right? Okay. Favorable. Suppose if I want to find the probability of rotten apple, what will I do? I will take the favorable outcome. So what is a favorable outcome in this case? Favorable outcome will be getting the total number of rotten apples, right? So instead of favorable outcome, I have written rotten apples. And in denominator, instead of total outcomes, I have written total number of apples, right? It's same only. We have 900 apples, so we have 900 as the outcome to select one apple from it. Okay, done. Now we have the probability of rotten apple, that is 0.18. We don't know the number of rotten apples. Let's take it x for a while. It's easy to write it rather than the long sentences and words. And total apples, total apple 900. So let's substitute the values. It's all about simplification. 0.18, let's say x here, and 900. Now you can see this is the linear equation in one variable. You solve it and get the value of x. Simple, right? So it's all about how you use this formula. Okay, at the start of the question you may feel like how to do this, we haven't done it, but at least follow the process. At least you know that how to write the formula very simple manner. At least write the values which are given over there and see what are you getting it. If you are confused, try to think over again. Okay, this 900 will be multiplied over here, and 0.18 I will be removing the decimal, that is 18 over 100 multiplied by 900 here is equal to x. So if I simplify, that will be my final answer. Now 18 nines are, that is 162 is equal to x. So x is what? Number of rotten apples, right? So there are how many rotten apples are there? 162. Now it is possible that they may ask you number of good apples as well. So what to do in that case? You can subtract 900 and 162 and get the answer. Here 10, here 10, then 9 and 8. So 8 here, 3 here and 7. 738 are the good apples and 162 are the rotten apples. Simple. This is the case of the reverse probability. We have the probability given and we need to find something else in this question, right? Let's discuss one more question similar to this. Let's do one more question. This is same as the previous one that we discussed. Let's start. A bag contains 5 red balls and some blue balls. Okay, 5 red balls are there in a bag, but blue balls number is not mentioned over here. It's written some blue balls. We need to find, I think. If the probability of drawing a blue ball from the bag is thrice that of red ball, find the number of blue balls in the bag, right? Okay, so first of all, let's mention whatever informations are given over here. Let's say this is a bag and there are 5 red balls are there and blue balls we don't know. So let's take it as X, okay, and red ball as 5. Done? Very simple. Now, first of all, let's talk about the total number of outcomes. Total outcomes is equal to, what will it be? 5 plus X. Generally, what do we do? If we have specific number, let's say 10 for a while, just for an example, then to find the total number of outcome, what do we do? 5 plus 10, that is 15. But in this case, we have X over here, so 5 plus X only. Simple. Now, one more condition is given, that probability of getting blue ball, okay, probability of blue ball is equal to, it's given, that is thrice of the red ball. Means thrice means multiply by 3 into probability of red ball. This condition is given. So, right, this is the condition given over here, that probability of blue ball is equal to 3 times multiply by probability of red ball. Now, before we use this equation or condition, we need to have probability of blue ball and probability of red ball. So let's start with that one. So first of all, let's find with the probability of blue ball. So probability of blue ball. Okay, favorable outcomes. What is the favorable outcome in this case? Favorable outcome means number of blue balls. How many number of blue balls do we have? That is only X. Okay, so that is in numerator, and total number of outcomes, that is 5 plus X. Simple, very simple it is, right? Number of blue balls over total number of outcomes, that is X is the blue ball and total number of outcomes are 5 plus X, right? Let's move on to the red ball. Probability of red ball. So red it is. So how many red balls are there here? 5, right? So I will be writing 5 over here, and total number of outcomes, that is 5 plus X, same as the previous one. Now I can use this condition to solve the equation. Let's start. So probability of blue is equal to 3 times probability of red. Okay, so probability of blue, that is X over 5 plus X, and here 3 into probability of red, that is 5 upon 5 plus X. Okay, this is what we have it now. Now see, this is just a simplification now. This is linear equation in one variable. If you simplify it further, now even there is a one more way. Now see, denominators are equal. Generally what I am trying to do over here, let's say X upon 5 and 4 upon 5, right? So if we simplify even, this 5 will go into numerator. Let's say X is equal to 4 into this 5 and denominator 5. So 5 will get cancelled, X is equal to 4. What you need to understand over here is, basically what I did, the denominators are same, so I cancelled over here, right? If I cancel the denominator in this step only, though I am going to get the answer straight, X is equal to 4, right? Same logic I will apply over here. See, denominator 5 plus X and 5 plus X. Here it is in product. Remember, if it is addition, we cannot do that. That will be the case of LCM. So 5 plus X cancel. So what's left here? X only. Here 3 multiply by 5. So X is equal to 15. So how many blue balls are there? 15 number of blue balls are there in this bag if we follow this condition. Let's recall one more time. We have red balls, that is 5, blue balls, that's not given, we are supposed to find it. So we have assumed as x. Then total number of balls will be what? 5 plus x, right? Red plus blue. Then one more condition given in the question itself, probability of blue is equal to thrice of probability of red. But we don't have probabilities of blue and red, so don't worry, find it. Okay, blue balls upon total balls, red balls upon total balls. Then apply this condition, simplify it and get the answer. That is 15 is the number of blue balls. Let's discuss one more question similar to this. Let's do one more problem related to previous one, reverse probability. Let's start with the question. A box contains 12 balls of which some are red in color. Okay, so there is a one box in which there are some ball which are of red color, right? Okay, they are of red color, no worries. And if 6 more red balls are put in the box and a ball is drawn at random, the probability of drawing a red ball doubles. Okay, so this is the first case. Let's write here case 1, and there is another case over here where, let's write case 2. You are adding more balls into it. Okay, you are adding 6 more red balls, right? Okay, so what is happening to probability? That condition is also given, right? Initially there is some probability, here so there is some probability, and relation between this probability and this probability is given over here. Let's see what is it that. Okay, drawing a red ball doubles. Okay, so double than what it is before. Okay, so let's say suppose that here probability is 1 by 5. So here it will be double. So 2 multiplied by 1 by 5. Right, if you add 6 more balls into it, probability will be double compared to the previous case. Remember, now what we need to find the number of red balls in the bag. We need to find the number of red balls. Okay, so let's start with the red balls because that's only that we need to find. So let number of red balls is equal to x. Okay, done. Now come to this part, case 2. Now here, if the number of balls are x, what will be the number of balls in this case? See, condition is what? You need to add 6 extra red balls, right? So let's write here number of red balls is equal to what? X plus 6. So this is the number of red balls. Now if we want to find the probability, we need to have total number of balls. See, it's given in the question. A box contains 12 balls. Okay, so total number of outcomes, or you can write total number of balls. Let's write here total balls is equal to, in this case it is 12, right? Now what about this? Is it 12 here or something else? That you need to think. Right, let me just write first of all sentence, then we'll discuss. So total balls is equal to, okay, see here it is 12, but you need to observe one thing. This 6 red ball, if you are adding this in this red ball category, why are you not adding in this total number of balls as well? Right, because total number of red balls will be increased by 6 compared to the previous one. Right, if you add 6 over here, you need to add 6 into this total balls as well. So that is 12 plus 6, that is 18. So here total number of balls are 12 and here total number of balls are 18. See, we are adding 6. We added 6 into red balls. We added 6 into the total outcome as well. Okay, now let's find the probability of getting the red ball. Probability of getting red ball. What is the number of red balls? That is x plus 6. Okay, and denominator 18. Let's do over here probability of getting red ball. Okay, number of red balls are x here and total number of balls 12. Done. So this is the probability in the first case and the probability in the second case. Now what we want to find, we are interested in finding the x. For that we have one relation over here. See, it is given the probability of drawing a red ball doubles than what it is before. So probability in the first case, right, probability in the second case will be double than the previous one. So indirectly I can write this is equal to this probability multiply by 2, right? Let me write one more time. Let me put p dash here to avoid confusion. So I can write p dash r is equal to 2 multiply by probability of getting red. This is old one. If you're still confused, this is the old probability of getting red ball and this is the new probability of getting the red balls. Now let's solve it. P dash r, that is x plus 6 divided by 18 is equal to 2 multiply, see, be careful over here, we need to multiply by 2, doubles, right, x by 12. So x by 12 it is. So 2 1s are 2 6s are, right? So okay, x plus 6 here over 18 is equal to x by 6. Now let's cross multiply it and it will be easy to solve. 6x plus 6 6 are 36 is equal to 18x. Then let's put this, shift this 6x over there. So 36 is equal to 18x minus 6x. So 36 is equal to 18 minus 6, that is 12x. So value of x is, guess what, 3 it is, right? Because 12 1s are and here 3s are. So value of x, our final answer, x is equal to 3. I have drawn 3 as well. I was not aware of the answer, though I don't know why have I drawn 3. So it's all same, no worries. So let's discuss one more time. So there are two cases over here. Previously what we discussed was blue and the red ball. Here no information is given about other balls in the bag, only about the red balls, right? So this is the case 1 where you have the initial condition, right? There are x number of balls and total 12 balls. So probability will be x by 12. But what you do afterwards, you add 6 balls into it. But specifically it is mentioned what color of balls are there, that is red. So that will become, okay, initially we had x number of red balls, now x plus 6. What about the outcome? Initially total number of balls we had 12, now we have 12 plus 6, that is 18. Now condition given over here that new probability is double than the old one. So we use the relation and we find the value of x. So this is how we find the specific information from the probability which is given into the question. So these all were questions were related to reverse probability.